You can make this procedural geometry node setup that subdivides the cube, and you actually have a lot of control over it. The seed, the randomness, the amount of selection, and so on. And you can even replace the cube with spheres, or any other object as you like. First, in geometry nodes, add the cube, and on each of those vertices we're gonna add another cube. And for the next iteration, scale instances by half. And just to demonstrate, realize instances, instance on points, another cube, and scale it down. And if we just repeat it, we're gonna get the basics of the effect. But there is no randomness, we just subdivided more and more with each iteration. To actually make it interesting, we're gonna start here, and this part is gonna be repeatable. First, we're gonna use a random value to make it so that only some of the instances are scaled down. And we realize only those that have been scaled down. Now, here it kind of looks like everything is cubes, but actually those small ones are actual geometry and the big ones are just instances. By using separate components, we can actually see the different components of our object. Here is the actual realized geometry and here are the instances. So we instance on points of the mesh, and then for instances we just join them with what we get. And that's actually mostly it, but we're gonna need to adjust it so that it's more repeatable and random with each iteration. We would have to manually adjust the scale of each iteration, which is not feasible. So we add capture attribute in instance domain and connect that into the scale of the instance on points node. And make sure the size of the instance cube is 1 by 1 by 1. To avoid any confusion, just copy this. Next, we're gonna delete some of them by using delete geometry, instances, and random value in Boolean mode. Next, store named attribute, instance, vector, and connect instance scale into it. And this is actually it if we manage to put everything between here and here into the repeat zone. Add the repeat zone and connect it here, here, and this goes into the output. And now you can just increase the iterations and see the subdivisions repeating. But there is a problem with randomness. You can see that big cubes never get subdivided. That's because each iteration randomness actually doesn't change, and that doesn't allow the big cubes to get subdivided. To fix that, add integer node and add the number of current iteration into the math node. That way we can still control the random seed, and just do the same for the randomness of deleting the cubes. You can add a different value with maybe different random seed to control the random value for each iteration, so that each time, each iteration, we don't delete just 10% of the cubes, but we actually delete a random amount between 0% of the cubes and 10% of the cubes. And you can probably do the same for the subdivision, for when you pick which cubes to subdivide, but it's fine. Now, maybe we want to keep going, but some of the cubes got way too small. They have been subdivided each iteration. And if we keep increasing the iterations, it will get too heavy. To fix that, in here, I'm gonna frame those nodes and name it selection. So output of this frame decides which cubes get subdivided. And we can actually limit it by adding and using sc1 attribute that we added at the end of the repeat zone, separate xyz, x greater than, and let's see, we have 7 iterations, and this is the smallest cube we can find. And if we adjust this value to, let's say, 0.1, it increases the minimum allowed size of the cubes. So when cube has been subdivided enough and got small, it doesn't get subdivided anymore. And once you set the minimum size limit, you can play around with the scale, selection, and iterations a lot more freely without your computer freezing up. Now, it looks good in wireframe, but if we look at it in rendered view, it's just flat. To fix that, convert instances to points, and those points actually keep the attributes of the instances. So, to control the radius of the points, we're gonna use the sc1 attribute that we saved. But I do that just for preview, radius is not actually important. Instance on points, cube with that scale. And we kind of get the exact same result. Why? Well, now you can set the scale of the cube to make it a little smaller. Now they don't fit perfectly together and we can actually see some separation. You can even add icosphere, radius at 0.5, and they fit together very nicely. Set shade smooth, set material, and give it a material. I'm gonna make a new one. And instead of using cube or icosphere, you can actually add another object, maybe add bevel modifier or whatever you want. And now we can instance that cube with rounded edges. But because that cube is 2 by 2 by 2 meters, make sure to scale it down by half. And in the material, I'm gonna use my favorite setup, object info, white noise, 1D. That's gonna give us a random value for each of those cubes between 0 and 1, or between 0.5 and 1, whatever you want. And now if we duplicate it and adjust the value in the math node, we can get completely different randomness. And add one more, and add hue saturation value node, and connect everything. Give it a color, let's say green, and now we can trap the hue between like 0.4 and 0.6 to get generally random random color, but it's still kind of green because hue doesn't offset too far off green that we have. Connect that into color, and now we can add some glass. Glass BSDF, mix shader, and use the same randomness but of different seed to control it. And if it's greater than some value, it becomes glass. I do love how glass looks on rounded cubes. It's really cool. And now for the routine, boring or fun part, adjust the randomness until you get the result that you like. I like when the big glass cube is in the corner. And now emission shader, another mix shader, another randomness, connect everything and make it so that there are just a couple of very bright cubes. And yeah, just play around with randomness. There is plenty of sliders and connections. You can control which ones are getting deleted, how many getting deleted, which ones are getting subdivided, how many are getting subdivided, and so on. Just have fun with it.